I want to talk to you about Chinese parts, Chinese tools that are imported to the United States, where we're sort of like fed up with the quality of the parts. And they say, well, they're cheaply made, so that's why they could sacrifice on the quality. Really? When we don't have a choice in the matter, we Americans live in the United States don't have a choice of quality tools, quality parts for our equipment. We don't have a choice for that. It's what it is. No. Let me give you an example about this American made in Bridgeport back in the 50s. Singer sewing machine. It's a double needle industrial sewing machine. Basically a high speed double needle. Okay. But when I acquired this, the tension regulators needed to be replaced. So this all the assembly here. The rotary hooks needed to be changed out. And the thread guides and stuff, okay? So the only parts were available for this machine were made in China. If you look at everything the thread touches, okay, the original post, that's still the Singer post. These two thread guides are still Singer post, or still Singer. But all the mechanics, this is all Chinese. Your pickup arm, that's still a Singer. Okay, Chinese, the needle bar, and that is Chinese. The rotary hook and everything out here is Chinese. The floor plate and the bottom feed dog is all Chinese. Okay? Chinese made. What is the significance of that? Well, let me show you. Okay, now I want you to listen to something and turn up your volume to hear this. Okay? Ready? You hear that crunching? That crunching sound? That is right here. Listen. That is the sound of the thread fibers being ran across sharp edges. Okay? And I'll show you where. All that is the thread being stretched. Okay? So the thread goes through here, and if you look right where this string is at, let me get it. Let me see if it's tight. Yeah, it's tight. Now watch. You see that click right there? You hear that clicking? That's sharp edges right there. You see that lint buildup right here? That's from the thread being scraped against this sharp thread guide, Chinese made. On top of here, behind the thread, on the ledge, lint buildup, Chinese made. Look on top of the your pressure foot. See all that lint buildup? Chinese made. Okay, and then if you look right here, again, Chinese made. This is where Singer messed up when they put out a new sewing machine. They're in such a hurry to get everything into production, is that they'll make a prototype saying, "Oh, this works, just throw it out." But old Singer sewing machines have a lot of flaws in them, and they kept on upgrading them throughout the years. But what happens is when they went out of business and then all the patents were sold to the Chinese, they made them according to the old prototypes. They don't pay attention to detail. Let me give you a perfect example. See this tension regulator right here? This sets the tension of your threads. Now, if you look at the inside of it, you see where it's cut. And that's cut. The angle is actually in the path, is in the thread path. Okay? So you have a potential of the thread being ran across that sharp machined edge right there. They needed to knock off that cut. They cut it too deep into these tension regulators. And you could tell that because there's lint inside these discs. Okay? Because the thread is being ran across that milling, that cut right there in this stud. Okay. Again, not paying attention to detail, piss poor quality. Okay. Again, the thread guides, all sharp edges on the thread guides, all Chinese made. The original Singer ones, they were more rounded. Everything had a rounded edge on it. Okay. And then we'll go to the bottom and show you the bottom. Now, here's the bottom of it. You see this hole right here? Okay, and you see that brown thread? That's the bobbin thread. Now the needle's going to come through here. See, there comes the needle. There's the blue thread. This is the thread off the spool, the top thread. The needle comes down and it's going to come to a stopping point. And then it's going to back up, and when it does, it's going to create a loop. Okay, keep watching. See, now it's starting to form the loop, and now you can start seeing the hook point right there. Watch this point hook. It's going to go grab that loop. And I grabbed it. Okay. I'll back it up. Okay, we'll go one more time. Now, as you can see it being pulled around here. So now it's being pulled around right here. Okay. Now look at the hole. Watch the hole and watch that thread being scraped against that hole, that rough cut hole. Hear it? See that thread being scraped across it? Okay. Let's do it one more time. There comes the needle. As it comes down, it's going to form a loop. Okay, this is where I want to talk about timing. of a sewing machine. Everybody hears about timing. But what we're looking at is timing in action. And how do you adjust this? Well, the setup is you could see the rotary hook point entering the needle scarf. The scarf is that indentation right above the eye. You want the point of your rotary hook right in the center of that needle, okay, as you can see right there. Now, the specifications for the needle travel is the most important part. From the bottom point where the needle reaches the very bottom of its travel, you want the needle to rise at the following. And the following is 90 thousandths of an inch, or 3/32 of an inch, or 3.5 millimeters. Okay? All sewing machines are the same. That's how it works. Now, each sewing machine is different on how you adjust that, on how you make the adjustments, but that is how a sewing machine works. Now it's coming around. And you could see it, watch that hole. You could see that blue thread being just scraped across that hole, leaving thread fibers behind. See all that lint built up on this rotary hook as it goes by? That's all the lint fibers being thrown off the thread. There you go. Because in real life, this thing is, it's going this fast, And I'm just doing this by hand. Can you imagine this doing by the machine? So it's, and this is what I mean about the quality. It's very important that the feed dogs, all of that, they need to be machined, not just cast with just rough ass metal and just simple with a drill bit and a drill and just drill a hole and call it good. You have to dress up those holes. I fixed this one. I took a round file and I filed what I can off of it. I did the best I could. I have you could get what they call string emery cloth, and it's a string form. So I gotta finish this up, polishing those holes off with that string emery cloth. I'll show you how that's done. But this is your Chinese. This is what happens. Now, why are we in this situation where we have no choice, but we have to put up with this? And who is this to blame? It's we, the American people, that have to be blamed for this. We're the ones who vote in the stupid ass politicians that want to go to corporations like Singer, like Briggs and Stratton, all the American manufacturers that had good quality tools that were forced to go to overseas because the government decided, oh, I want to be reelected, so I want to give the American people this and give the American people that so they could vote me in again. But we don't want to raise their taxes, but we'll raise the corporate taxes to 75%. They don't need to make billions of dollars. They don't need to make millions and billions of dollars in profits. That should be so we could spend money, for projects so we could get reelected again. Well, what happens is that when you have companies like Singer, who makes these sewing machines, and when they come out with a prototype and to put it in production, then they find out, wait a minute, we need to improve on this, we need to improve on that. Well, when you have to change your tooling and do research and development, that costs a lot of money. Well, that money comes from their profits. So when the federal government takes 75 cents out of every dollar out of their profit money, then that doesn't leave them much to they can't operate that way. They could barely have that there to cover their operation costs, much less research and development and improve on the product that they're making. So if they want to stay in the States, what do they got to do? They either got to cut their labor force or cut costs in what they're making. Then they got to make less quality parts. So either we get the less quality parts from China or we get the less quality parts made in the United States. You know, because of the outrageous taxes that the corporations are forced to pay. You know, let the million and billionaires pay for it. Oh yeah, well your millionaire and billionaires are your corporation owners or your CEOs and stuff that are in charge of all of this, and they have no choice. You know, they can't sit there and say, well, we're gonna, they can't afford to operate in the United States because of that. And we are the blame because we are the ones who elect shit politicians in the first place. So the philosophy is if you got shit coming in, you're going to have shit coming out. And we got a lot of shit coming out of Congress right now. We have been in the last years and years and years and years. Because every time they want to do something, they always tack the manufacturing, EPA regulations, and stuff like that. They make too much money. Let's tax them. Oh, they're polluting. Let's fine the hell out of them. Oh, they're doing this. Let's fine the hell out of them. Let's get more money out of them. So that's why we are in where we are right now, and that's why I got to put up with shit like this, where I have to sit there and put about another 8 hours worth of work on grinding these hose down and machining these out to where you don't have all of this lint buildup and thread breaking. Okay. Before this, I couldn't run. I'll show you here. Let me shut this off and I'll show you what I was doing. When I put these new parts in, if you look right here, see how this thread was starting to fray out. That's because that's before I did any work on any of this stuff. Okay, that was being frayed out. It broke there. It broke right here because it was fraying out. Right here, another place it broke. Here, it frayed out. Right here, it was fraying out. And let's see. But anywhere where you see it right like this, it's where it was fraying out. Here it was fraying out. And the reason I use vinyl because vinyl doesn't create lint when you sew with it. So all that lint was coming from the threads. Okay, now we're going to do a test on this to see when the thread breaks. Okay, I'm going to run this machine where the thread will break. It will break before it gets. So I'm going to see if I could do this. It's going to break before it runs to this stretch of material, and it's probably 15, maybe 20 inches. Okay, I'm going to run at full speed. It will break probably around this point because the needles will get hot and the thread will just break. Okay, but if it breaks before that, if it breaks anywhere within, you get this little hump right there, which I put in purposely because I want to go from 2 to 4 to 2 again, layers. If it breaks before then, it's because the thread is being frayed. It's going to end up like this. But we're going to see if it breaks because of a frayed or breaks because it gets hot. So here we go. Start out slow. Ready? Okay. What do we have? Well, we got a mess up here. It looks like the light blue thread. Okay, let's look at the edge end of it. Yeah, the thread was being frayed. What do we got here? The dark blue thread. That broke towards the very, very end. So that broke because of the heat. Okay, let's see. Here's the dark blue thread, right where my finger's at. So let's follow where the light blue thread let go. This is where the dark thread broke, and it broke just because of heat. So we follow this up, follow this up, follow this up, follow it up, and right there, this thread broke right here. It's this one right here, because this is where we started. Right here is where we started. So it went down here, started to get frayed after it jumped this right here. You can see where it was fraying, and right there is where it let go. So the light blue side is the one that frayed. The dark blue side broke because of the thread overheated. So, lesson learned, right? The lesson learned is we Americans need to be smarter about our politics. We need to know who we're electing into office. So I got to get emery cloth and round that all that crap out in there. Make everything all nice and round so it doesn't. It's okay if it jumps the gap, just as long as it doesn't reach any sharp edges. You think people who make this stuff too, that they would, do you think that they'd, yeah, they want to make stuff cheaper. You think they'll take a little bit of effort to say, wow, look, here's a problem that they've been having with this patent. This is the problem that Singer's been having. Why do we want to copy it? Let's make it better. That's why the Japanese industrial sewing machines, your Zukis that are made in your consoles that were made in Japan in the 70s and 80s and 90s were better than Singer, the Singer machines, because what they did is that they took and stuff like this, they would say, wow, we're going to fix this flaw, okay? We got a flaw right here. We're going to go ahead and fix that. And then you also incorporate new features. Like some machines, there's a knob down here that you could turn. It'll drop the feed dogs, and then you could free sew, and you could do embroidery and designs, move your fabric around anywhere you want to go with it and make a design with it because the feed dogs are out of the way. But Singer didn't do that. They didn't come up with that design. It came up with your foreign manufacturers who took the patents from Singer when Singer went out of business because Congress forced them out of business. So there you have it. But anyway, that's why the light blue thread, it was rubbing there and it was rubbing on this bottom feed dog, which I got to round out and then fix this and then fix this and then fix this and then fix this and then do the same thing with these holes here, these guides here. Got to round those, take the burrs and round those out. So you're probably looking at about 2 hours worth of work right here. And this is just for one guide. Because if you look, this is set for, I think this is 1/2 inch. Yeah. And I got 8 different widths. And they all have the same problem with the thread, with the sharp edges and stuff, because the machines weren't done. So, yep. There's no other choice. I mean, it was the only people who were making this stuff. Okay, how do we fix all of this? Okay, I was talking about that cord, and it's this Mitchell's. Right there it is. Okay, and this stuff right here is the it's the 55 thousandths, abrasive 52. Okay, and it comes in from sizes from 12 thousandths to 150 thousandths. Okay, so this stuff right here I got is 55 thousandths of an inch. And it's just, let me pop it open. It just comes into a spool like so. And this just came in the mail yesterday. This is one of the thicker rows I got. The other one didn't come in yet. Like say, here is a here's a feed dog that I wanted to do, but the hole is just a little bit. This is a little bit too big for this hole right here. But what you do is, I'm going to use this hole as a demonstration. You just put it through a hole like so. Okay, and then we get a longer piece here, like so, and you just work your way through there, just like so. You just come around this side. It doesn't take much. Okay. And you can see it leaves a lot of residue, so you really don't want to do this on the machine. And it just makes it rounded out. So, but we shouldn't have to do this. We should not have to do this. But we have no choice.